Okay. Okay. So we have new topic today. We have connected particles. This is simply, you can say, extension to the previous things that we have done. We know about how to resolve forces. We know how to work with the friction. We know how to do F is equals to ma. We know how to do kinematics. So when you combine all of these things together, this is some another situation how all of these things can be combined. We call it the chapter of connected particles. When you see the syllabus outline, you won't get a separate topic out of this complete thing, but these are very unique type of questions. So what happens over here? Connected particles means that definitely particles would be connected. So you can have two particles connected most of the time, 95 or 95, 99% of the time. Two particles are connected together by mostly by strings, by ropes or anything. By strings. Inextensible that we did about the strings previously as well in forces, where we had tension. So we learned about the strings when the particles were connected together by strings or something was hung at a wall from the wall. Yes, from the what do we say the ceiling. So strings when two particles are connected using a string, and you will see over here that you would have pulleys, frictionless pulleys, and for example, there's a pulley right like this, a very basic example, and there is a string which is being wound around this pulley like this, a single string, and there's a particle over here and there's another particle over here. So if we think about it, if both of these particles would have the same mass, so what would happen? This would be the weight of this thing would be pulling it down on the left side, and the weight of this particle, let's suppose this is A and this B, so both of the weights would be acting downwards. So due to the weights, what happened? We know that this string, this is a single string. I told you about the strings as well. Whenever you have a single string, the tension in the string is constant. We have the same string, sorry, we have the same tension over here on this part of the string and same tension on this part of the string in such a way that the directions, you have to understand the direction how the tension works. So here in the string, the tension would be upwards, and here in the string, the tension would be upwards, which would be cancelling out the effect of the weight of the B. So these both particles are connected by this string, and the string is taut. Taut means that the string has tension. There is a force of tension between them inside the string has tension. If think about it in your mind, if I pick this, what do we say? If I pick both of these masses up by hand to this height, if I am picking up the masses by hand on both of these, so the string would now become slack. We call it slack because now there would be no force of tension inside the strings because the weight is now being held on by my hand. Do you get it? So the opposite of this taut string being taut is opposite is string is slack. When the string is not supporting the mass, when the string is not tight, this means that the string is slack. There is no force of tension inside the string because the string is now what do we say, slack. I don't know what is the other better word for slack. I hope that you understand this. We'll have situation like this. Okay. So what do they ask you in this situation? You can have a situation like this, a simple string. Sometimes they can also include a slope as well. For example, you have a pulley over here, there's a mass connected over here, and there's a mass which is hanging over here. So both of these particles are again connected. So we have to work around the forces and we have to create F is equals to ma for both of them and see if the particles will move or not. We can have friction over here as well. With this particle, they can involve the friction as well. So all of these things now they are involving. So what happens is we have just particles, they are connected. So we create F is equals to ma for both particles. We resolve the forces, and we see if the forces are the sum of the forces are what do we say, uh, causing any motion or not, by equating them together. So for B, for particle A, we would do F is equals to ma, and then for particle B as well, we would do F is equals to ma. And when we get this equation, we solve them simultaneously to get the relevant information, to get the combined acceleration simultaneously, to get the common acceleration or the tension in the string. You will see tension in string, because when this string is taut, this means that that the force, there is a force of tension between in the string. At that point, the masses are connected to each other. So what will happen? Any one of the weight would be higher than the other, would be more than the other, and that would cause that part to go down. Let's suppose this is heavier. This is of 2 kg, this is of 1 kg. So my logic in my mind says that definitely because this is heavier, it would have more weight, and this would have less weight. So because of the sum of them, sum of the system over here, this would go down because this is heavier, and definitely this would go up. So because they are connected, their direction of movement would be different, but the magnitude of acceleration would be the same, because both of them are connected. Connected means that their motions are connected. Okay, so both have connected motion, or what do you say, have same acceleration, magnitude of acceleration. Direction can be different. Direction, one of them will go down, the other would go up. Direction will be different or can be different. As long as the string is taut, as long as the objects are connected, can be opposite or different, you can. So can be opposite is better. So this is the overall idea what the chapter is asking you to find. Okay, we have to one thing would be falling down, the other would be falling up, and then they can involve kinematic over here. Whenever we have motion, when we have acceleration or velocity or time, then they can ask you how much time does it take to reach this point, and then this and that, and how much displacement in 5 seconds. Everything is the next part is the same as kinematics. The main thing over here is to resolve the forces as a connected particles, and then this part, get the common acceleration for both of them, and the tension and the strength. This is the overall concept. This is what we would do. So let's take a small example. Now let's suppose there is a pulley, a straight position pulley like this. Sorry, my drawing is not very good. And they would say that this pulley is frictionless. Okay, because if it would have, it would, if it has friction, then the system would be something else. Then we would have to consider the force of friction inside the pulley as well. Let's suppose this is particle A, this is particle B, and they are held, let's suppose 2 meters from the ground. Okay. The mass of A and B are 2.5 kg and 3.5 kg respectively. Find the tension in the string, tension in string, and the time it takes for one of it to reach ground. Okay, we don't know right now which one would reach the ground. Okay, so we have to time, we have definitely one would go down, the other would go up, because these are connected. So let's reduce this time, this distance. So let's make it 0.75 meters. Okay. This is the ground. First of all, we have to again make sure of all of the forces that are involved over here. So this would be the weight of A. The mass of A is 2.5 kg. 2.5 kg. And the mass of B is 3.5 kg. So the weight of A would be mg, which would be 25 Newton, simple. And the weight of B would be 35 Newton, mg. And definitely the force that would be opposing both of these weights would be the tension in the spring. The tension in the spring. Okay, both of the tensions are opposing the weight. Over here, the tension would be like this. Okay, so this is the direction. We have learned about how to give the direction of the tension force. One place the tension is pulling something, and the other point, the other end, it is pushing something. So if you need a revision, we'll do that. Otherwise, you can watch the recording when we were doing the forces, the basic forces thing. So this is the situation. Now we have to make F is equals to ma, the sum of F is equals to ma for both of these equations. So what happens for A? What's, for example, for A, I'm making the force. Right now, we have to assume whenever you have situation right now, we have to take an assumption. Which one would be moving down? Logical assumption, okay? Even if you make the wrong assumption, you will get the right answer, but the direction would be the opposite of what you've taken. Right now, the assumption is very simple and a very logical one, that definitely B is heavier. It is of 3.5 Newton, so B would go down. So B is going down. This is right now the assumption. So for A, if we know that B is going down, then for the F is equal to ma of A, if B is going down, then A would be going up, isn't it? And if this is going up, then the tension would be greater than the weight. That's why it is going up, because the force, there's a resultant force upwards. So for A, the equation would become T minus 25 is equals to ma, 2.5 times A. And for B, the equation becomes, now we know that B is going down, so the weight component is greater than the tension. That's why it is, the resultant force is downward, and that's why the acceleration would be downward. So 35 minus T is equals to 3.5 A. So we have got the two equations. If you can find these equations correctly, then the rest of it is a piece of cake. Now you solve them simultaneously. So when you would solve them, this T and T cancel out. So 35 minus 25 is equals to 6A. So this comes out as 10 is equals to 6A. So acceleration is coming out to be 5/3 meter per second square. So this means that the B, I have taken my assumption right, because my assumption was B is going down. So B is going down and the acceleration is coming out as positive. So this means that actually the B is going down and A is going up. If I would have taken a wrong assumption, then I would get an answer of negative 5/3. This would suggest that if I would have taken the assumption that B is going up, so I would get an acceleration of negative 5/3. So the negative is now denoting that the assumption was wrong. The B is actually going down. So even if we are making a wrong assumption, you would get the right answer, but the direction would be opposite. You have to understand this. After a few questions, you will get a better idea. Okay, don't worry about this. So we have now got that the assumption is right, and we also found the acceleration. So B is going down with acceleration of 5/3, and A is going up with an acceleration of 5/3. And the tension, to find the tension, you can use any one of the equation. 2.5 times 5/3. So tension comes out to be 2.5 times 5/3, and then plus 25. So the tension is 29.17 Newton. This is the tension in the spring. So we solved it simultaneously. We found the acceleration and we found the tension in the spring. String. Why do I say spring? Okay. Now the next part, once we've got the acceleration, the next part is kinematics. This is going down. with acceleration of 5/3. This is going up with acceleration of 5/3. Now, how much time is it taking to reach the ground? So the displacement is 0.75. To reach the ground, it has to displace 0.75. So you can use S is equals to ut plus half at square. So S is 0.75. Initial velocity is 0. Initially, I should have written it down that the masses are at rest. Masses are at rest initially at the same level, at the same height, you can say. Okay, so now we can solve this. So ut initially it is now rest. Time is, we don't know, plus half. Acceleration is 5/3 and time is square. So now we solve this and then we get the value of time. So how much time it took to reach this, what do we say, the ground? 0.75 times 2 times 3 divided by 5, 0.9 is equals to t square. So under root of 0.9, it is 0.9487 something. Okay, this is the answer. That's it. Or you can write square root of 0.9. This is the seconds. This is the time it took for B to reach the ground. Okay, that's it. This is the complete answer. Connected particle, we solved, we got the equations, and then we solved them, got the connected, the combined, or what do you say, the common acceleration and the tension in the spring. And then we use the acceleration to further solve it using the kinematics, the simple equations of motions. Okay, all good till here? Any questions?
No, sir.
No, sir.
This is where the part of the, what do we say, connected particles thing is over. This is the part of the connected particles, how you form the equation and get the acceleration and tension. The next thing is they can now make something more interesting like this. Find the maximum height reached by A in the subsequent motion. Okay, now we know, if you keep the situation in mind and if you think about the aftermath, what happens after this B reaches the ground? So B is reaching ground and it is going to travel 0.75 meters. And definitely the distance that B has gone down, A would have gone the same distance up as well, 0.75. Okay, all good till here? Because both of them are connected right now. As long as this B is moving down up until it reaches the ground, the A and B are working like a connected particle. Once the B has landed here, has now touched over here, it's not bouncing back, it has just landed over here. This came and then sits on the ground. The A would have moved 0.75 and it will also move a little bit more, isn't it? Because when this A has moved 0.75, it must have reached a velocity, and because of the velocity it would have traveled a little bit more up until its velocity at the maximum height have become 0. Do you get it or not? Let me explain it again. This is 0.75 meters. Okay, and definitely this would also move 0.75 meter, because as long as it had not reached the ground, they were connected. Now this is the distance that A has traveled. Once B has landed on the ground, but A would have some velocity over here, right? A would have some velocity over here, and because of that velocity, the velocity would have taken it slightly higher, and at that point the string would become slack, because now the tension would become 0. B is landed on the ground. There is no tension in the string. So for this part, for this subsequent motion, the string is slack but because of the velocity over here of A, it is going to slightly move more upwards and then reach a point where its final velocity would become at the maximum position. So this is the height which they're asking us, the total height, the maximum height and the subsequent motion that A has reached. Any questions over here? All good? Nuba, Nadia, Murtaza, Hamaz.
Yes, sir,
Yes,
all
sir.
good.
This is one of the interesting questions. You will see this type of question past paper. So first of all, we'll have to figure out what is the velocity of the A once it has traveled the 0.75 meters. So for that thing, we can use 2as. 2as is equals to v square minus u square. Now we are working for A. Okay, everything is for A. 2as is equals to v square minus u square. 2 acceleration upwards for A was 5/3. Distance we know it has moved upwards 0.75 is equals to final velocity we want to find, initial velocity was 0. Here, therefore, the velocity of A becomes 2 times 5/3 multiplied by 0.75 and then the square root. So square root of 2.5. This is the speed of A. This is the B. This was the initial position, you can say. B has traveled 0.75 down. A has traveled 0.75 up. This is your A. And the velocity at this position we have found it is under root 2.5. Now the string would become slack. After this point, now string is slack. Tension would become 0. So there the acceleration will now only be due to gravity, which would be downwards, which would be g, which would be negative 10 meter per second, because now it would be moving in the free fall motion, like you can say. So now we want to find how much more it can go above the maximum height. So at this maximum height, the velocity would become 0. So 2as is equals to v square minus u square again. So 2 acceleration is now negative because now the acceleration due to gravity is going to stop it, trying to stop the vertically upwards motion. So minus 10. Displacement, we want to find it out. Final velocity would be 0. Initial would be under root 2.5 squared. So this is square under root cancel out. So your S comes out to be negative 2.5 divided by negative 20. So 0.125 meter per meters. So this is the more displacement that it has covered, 0.125 meters. So how much is the total distance? How much is the total height? It would be 1.5 plus 1.5 plus 0.125. So it would be 1.625. 0.75 plus 0.75 plus 0.125. 1.625 meters. We'll do more cases. We have very similar cases when one of the one of the masses is standing on a plane, on an inclined plane. The logic is the same. Okay, the situation can change, it can vary, but if you know the logic, what are you trying to find, how the things would work, then it's easy. Okay. Okay, let's see another situation. So look, these are another cases. I made cases previously, but you can have something like this, or you can have something like this. The plane is inclined or plane is horizontal, and then these are all of the cases. We don't need cases, we'll do some questions. This is, you can say, another case. The next one of it is inclined. No, right now we can't do this. This is the, I think, maximum difficulty. This is one of the good questions. Let's do this one. This one you people should try first, and then if you don't get it, then we'll discuss. You can say this is the second case. Okay, so two particles, so P and Q of masses, they have given us the mass of P is 1.7 kg and mass of Q is 0.3 kg, are connected by light in extensible string. P is held on a smooth horizontal table. Smooth means no friction. Smooth horizontal table, no F max. So easy. With the string taut, passing over a small, smooth, fully fixed as the edge of Q is at rest vertically below. P is released. Find the acceleration of the particle and the tension of the string. So easy 5 marks. We have to first of all write down, assess all of the forces that are acting. So Q has its weight vertically downward 0.3 G and a force of tension upwards. Weight of P is downwards 1.7 G and tension is pulling it to the right side. So definitely for the motion of P, it is not going to move up and down, and we don't need to resolve the forces of P vertical and the vertical direction, because T is going to move horizontally. So there is only one force which is pulling the P towards the pulley, that is the tension. So if we make the equations for Q and for P, for Q, definitely the assumption is right now that Q would go down. So the weight of Q, which is 0.3 G, minus the tension is equals to 0.3 MA. F is equals to MA. Then for P, there's only one force which is going to pull it to the right side, which is T, is equals to 1.7 A. So now you solve for both, solve them simultaneously. When you would add both of the equations, this and this cancel out. So you get 3 is equals to 2A. So your acceleration comes out to be 3 upon 2 meter per second square. And your tension comes out to be 1.7 times 3 upon 2. I put this A acceleration over here in the second equation. So this comes out to be 1.7 times 3 upon 2. 2.55. That's it. That's the answer. So I don't know. Easy 5 marks. What were these 5 marks for? Easiest 5 marks. Any questions over here? Nuba, Nadia, Murtaza, Maz?
No, sir.
They can involve now in the next part, if it would have any the kinematics. How much time is it taking for P to reach the pulley? Okay. So anything. The next part is simple kinematics. Let's see if we have any good questions. Okay, let's assume this one. Particle A and B of masses 0.9, 0.6. Let's make it smaller. Particle A and B of masses 0.9, 0.6 are attached to the ends of a light and thin extensible string. The string passes over a smooth fixed pulley. System is released from rest with the string taut with its straight parts vertical and with the particles at the same height above the horizontal floor. So they have not given you the diagram, but they have explained everything. So they have given us that there is a floor, and then there is a fixed pulley, and then both of these masses are vertical and on the same height. So this is your A, this is your B. And they have given the masses 0.9 kg and 0.6 kg. Everything they wrote it down in the paragraph. In the subsequent motion, B does not reach the pulley. So by this sentence, they have already given us the assumption that B is going up and A is going down, because A has higher mass as well, greater mass. They are asking us, find the acceleration of A and the tension in the string during the motion before A hits the floor. Okay. So we need the acceleration and the same thing. We have to find the same thing. So we have the weight, which is 0.9 G. We have the weight, which is 0.6 G. We have tension, we have tension. So much tension in life. A is going down, so weight component of A is larger than the tension. So 0.9 G minus tension is equal to 0.9 A. F is equal to MA. For B, tension minus 0.6 G is equal to 0.6 A. You add both the equations, tension cancel out. 0.9 G minus 0.6 G is equal to 0.3 G is equal to 1.5 A. So A comes out as 3 over 1.5, which would equal to 2 meter per second square. This is the acceleration. And if you want to find the tension, so T is equals to 0.6 times A plus 0.6 G. So 1.2 plus 6, so 7.2 Newton. This is the tension and the acceleration. We have got the first part. After A hits the floor, B continues to move upwards for. This is a very interesting one. Read the second part and see if anyone can give an input. Give an something. Let's see. A is hitting the ground. Floor B is moving more. Continues to move up vertically. After A has hit the ground, B continues to move up more by 0.3 seconds up until it reaches a maximum height. Now they're asking us find the height of the particles above the floor at the instant they started to move. So they are asking for this height, initial height. Any anything, anyone. Think about it.
Will it find the distance covered by B, and that will be the height?
How would you get the distance covered by B?
It'll be two equations, right? In first, we'll take V as 0 because it will start from the rest, and then another equation where V will be equal to the, sorry, U will be equal to the final velocity of the first equation.
But you don't know what would be the fine. You don't have the time. How much is it taking? You are very close. Definitely, this is 4 marks, so we need to find something. This is interesting. This won't be as easy, but let's see. Let's see. So you are telling me that the initial height definitely B would go upwards the same by the same height as well. Okay. When A is reaching the ground, B is going above in the with the same displacement upwards. And then after that, for this part, the maximum distance that it has that the B has gone, it is taking 0.3 seconds over here. So using this, we know final velocity over here would be 0. We can find the initial velocity over here. So V is equal to U plus AT. And at this part of the situation, there the string is slack. If you can recall, because this B is after A is reaches the ground, B is going further up. So at that point, the string is slack. So there is only the force of gravity, acceleration due to gravity. So final velocity is 0. Initial was we don't know. Plus acceleration due to gravity was minus 10, and time is 0.3. So when we do this, we find the initial velocity, which is how much? 3. So we have found that the velocity at this point for B is 0. Sorry, कितना था? 3 meter per second. Now what can we do? We know that initial velocity over here was also equal to 0. So, and the acceleration we know for this part when B is going up, we know the acceleration. While it is taught, acceleration is 2 meter per second square. So we can find the distance that B is going up, which would be, I think, 2as is equals to V square minus U square. So 2 acceleration is 2 displacement, we want to find it out, the height h, how much b has gone up, and final velocity is 3 square. Initial velocity, initially when they were both at rest, so 0 square. So your height comes out to be 9 upon 4 meter per second. Sorry, meters. 9 upon 4. So what are they asking us? Find the height of the particles above the floor. Yes, that's it. This is what they were asking. So the B, how much B has moved up is the same distance as how much A has gone down towards this, towards the ground. So this means that height which they are asking is 9 over 4 meters, 2.25. Okay. Any questions? All good? Do you understand?
Yes, sir. Okay.
Nuva, Nadia,
Yes, sir.
and Paz.
Yes.
Good. Let's confirm. Look, 9 upon 4. Okay, I'm going to give you people should try this one. I'm going to stop the recording. The chapter is over. There is nothing more over here. Okay, the logic that everything that I could have given you, I have given. I hope that you have understood it. You just need to attempt more different situations that the past paper is giving you. Okay, once you'll open up the past paper, you'll see how different situations that they are making. You'll have to use your mind every time. Okay, don't just, you won't get the same situation everything. The values would be different. Sometimes you can get a inclined plane as well. So they can involve everything combined together. They can involve friction as well. So you have to keep everything in mind. This is simple basics. You can feel everything in front of you in your mind and do it properly. Okay. Uh, okay. I'm going to stop the recording. This is the question that you people should try and then submit it to me. That's it for today's class. Stopping the record.